Oil is dripping from the compressor, meaning the air outlet from the compressor is leaking about this amount of oil. So one of the reasons for removing this engine was exactly the oil leak, meaning the oil was getting into the cylinders through the exhaust valve. The entire manifold was wet, all the joints here were wet, meaning the oil was being pushed through the exhaust manifold. The customer faced this problem and at first apparently replaced the turbocharger, thinking it was the turbo that was pushing oil. Then he replaced the compressor, but apparently the problem didn't go away, so he decided to repair the engine and send it to me. So when I was taking it apart, basically, there was some wear on the liners and on the rings, but I wouldn't say that oil was being pushed through the rings that badly. Maybe the reason for the oil getting in is actually the compressor, let's say. I mean, even though the compressor was new, maybe there are some problems with the cylinder or the rings, I don't know. The compressor itself is pushing oil, the oil gets under the head and comes out with the air into the air system, and some of it ends up here where we take in the air. Anyway, some of the air moves back and forth here, some of the air gets into the intake manifold, and then further on, the turbine pushes it through the intercooler into the intake manifold, and then from the cylinder heads, from the combustion chamber through the heads, it goes into the exhaust manifold. This means that our first possible cause could be in the compressor, I think, and the second possible cause could be in the breather. The breather's design is actually quite simple. There's a spring and a diaphragm in there. I replaced the diaphragm. The oil doesn't settle anywhere, so it goes through the pipe right here, and here it's actually very close. Yes, the air intake from the breather and the air intake to the compressor are very close, so I didn't do anything with the compressor, right? I asked the customer and he said the turbo is new, don't do anything, don't touch the turbo. The compressor is new, we don't do anything, don't touch the compressor. So I just cleaned all of this and put it back in place, and now we see that it's from the compressor. I literally just turned the starter and there's already a puddle of oil like this. Well, at the very least I'll be taking the compressor apart. Now we'll start the engine, see how it runs, and maybe we'll also see where the oil is leaking from. It comes out to exactly 10 liters. I poured in 8 bottles of 1¼ liters each, so that's exactly 10 liters. We can see the level. All my cylinder heads are completely filled with water. So you can run it a little, make the water circulate, manually circulate the water, get the circulation going, and then let the engine run. So I need to explain what's going on here. You saw some footage of me disassembling the compressor. I took the compressor apart, and as you can see, the compressor is separate from the engine. Maybe I should explain that the compressor was sent to me by the customer through a shipping company. This is the old compressor that was on this engine, meaning it's the original compressor that came with this engine from the factory. This compressor was replaced 6 months ago with one from the company YUNMAK, and we can also see that there is no turbocharger. In the footage of the engine startup, you can see that oil is coming out of the compressor. It's visible in some of the shots. And we can also see that there's still a drop of oil hanging here. Yes, I had a puddle of oil here and so on. And the turbine was also pushing out oil. So I sent shots like this to the customer. When you reach in here with your hands, your fingers come out shiny. That is, the oil is fresh, not black. Yep. It can still be black, but because there is carbon buildup in the cylinder, the fresh oil kind of dissolves that carbon. And that's why it looks like this. Here in the turbine we have fresh oil. It's absolutely not black, so we can see that there's oil in the turbine itself. Even though I first cleaned this turbine with diesel, then I washed it in a stationary washer with high temperature, but then I blew it out so the turbine was absolutely dry. But when it's running, we can see that inside, where the air comes out, oil has appeared there, and the oil is fresh too. So I sent a video to the customer and showed that oil is coming from the compressor, that there's oil in the turbine. It's not clear where it came from. Maybe it's some old oil, let's say from before the repair. Maybe it's pushing oil. Anyway, as the customer said, don't touch either the compressor or the turbine. So supposedly they're new. He installed them 6 months ago. Well, it's unclear, of course, for 6 months. What could have happened to them, how long they've been used, how they were working, and so on. Well, and after starting it, I sent the client a video just so he would be aware of what he has. Here oil is coming out of the compressor. Yes, somehow maybe it's old oil, maybe it's fresh, I don't know. You have to figure it out and check everything. And oil is also coming out of the turbine. So everything was already assembled and painted, and I was planning to just wait for the gears, install them, and send the engine to the client. Well, the client decided that something needed to be done with the compressor, something needed to be done with the turbine. Well, according to the rules, when an engine comes in for repair, I usually open up the compressor. Well, at least just to take a look. Yeah, because the compressor can push oil, and because of the compressor, the cooling system can get air in it. Also, for example, the compressor can simply seize up, and that can cause a lot of trouble too. Well, in general, there are many possibilities, many malfunctions that can be related to the compressor, so in any case, when repairing, I always check the compressor. As for the turbine, at the very least, we take the turbine in for repair, so it can be checked on a test bench to see if it's leaking oil or not, and so on. So, depending on the circumstances, we either install a new turbine, repair the old one, or leave the existing one. But in any case, it would be worth checking it at least just to see if it's leaking oil or not, to be sure about it. This should have been done during the engine repair. The customer said that the turbine needs to be taken for inspection and the compressor needs to be repaired. But we won't be repairing the compressor he bought 6 months ago, we'll be repairing the original compressor from this engine. So he sent it to me, I waited for it for about 5 days, got it yesterday, and we've already bought the spare parts. Here we have the cylinder, piston, sleeve ring pin, and here we have a gasket set with valve, so now I'm going to assemble it. So, I've also already received the gears. Here we have the gear from the camshaft, here is the gear for the compressor drive, and there are some other spare parts from this engine lying here. So now I'm going to work on all of this. So what amount of work do I have right now? I'm taking this part apart again, meaning I'm removing the pulley, taking off the pump, removing the front cover and replacing the camshaft and compressor gears. So I'm removing the compressor, unscrewing all these fittings and tubes. I'll need to transfer them to the assembled compressor. I also need to remove the power steering pump, basically disconnect everything from it, the mount, the oil line, and so on. I'll assemble this compressor, install it in place, connect all these tubes, fittings, the pump, and so on. So I'll install the compressor in place, put on another gear, close this cover here, install the pulley, and install the pump. The manifold is just loosely attached for now, without gaskets on a few bolts. So I remove the manifold, paint everything here again. Tomorrow the turbocharger arrives, I install the manifold in place, the paint will dry, I install the manifold in place, and then I install the turbocharger. Here the oil supply, oil drain, install the clutch basket and the new disc. Well, basically probably one more time I'll start the engine here on the table, that is with a different compressor and different gears. I didn't disconnect the diesel from it, so it's still connected. I also didn't remove the wires, so I'll just need to connect it. The batteries, so I'll probably start it without water. Well, I'll just start it for a minute, just to take a look. Basically, it was running for quite a while already, everything's fine. So, I had a chiz here, I showed the broken bolt. Now I still need to install the thermostat with this cover back in place. So, it turns out I still have a couple more days of work with this engine. Well, that's how it dragged on for us. So, at first I didn't immediately notice the gears, that some of them were chipped, that some teeth were broken. I didn't notice right away while we were looking for the gears. Then the issue with the compressor and the turbocharger came up, so we started dealing with that. So in the end, the engine was delayed. In repairs longer than planned, for 2 weeks, maybe even more than 2 weeks. Well, things happen, there are all kinds of circumstances, you can't foresee everything, that's it. So that's the amount of work we have. Let's get started. So let me tell you what has been done. I overhauled the compressor and have already installed it. So I installed the camshaft gear, aligned it by the holes, basically by the guide. Everything is good, it's installed, the bolts are in place, and I tightened the thread locker. So I've already set all the timing marks here as well. We can see that the crankshaft lines up with one mark. Here on the gear we have one dot. The camshaft lines up with two marks, and here we have two dots. And here the fuel one is kind of homemade. This is the clearance on the oil pump, and this is the clearance on the compressor. So I also set the clearance to 0.15 thousandths of a meter. That means this way the filler gauge goes through. Well, it's a bit tight. I made it so that it goes through with some resistance, and it goes through about the same way on the oil pump. That's it. So the clearance in the gears is set, and this lever has stayed pretty much in the same position. So when I took it apart, it was in this position, and now it's moved by about this much. Just to remind you, here we have an eccentric, so you can move the gear away from or closer to the camshaft gear. Here I also tightened the nut with thread locker and made a mark to show that it's tightened. I've already connected the oil supply to the compressor here, moved it, tightened the power steering pump, and swapped all the fittings here. This is our air supply, this is our air outlet, and this is our regulator valve for 12 or 14 atmospheres. It's already adjusted. So for example, when the air in the system freezes, this valve starts releasing air outside. By the way, it's very expensive. Here we have the coolant supply and the coolant outlet. Well, in general, I've tightened everything up and put thread locker on everything. I also want to see how to adjust this gap in the gear. The compressor must definitely be tightened. That is, I put these 12mm nuts here and used the standard 10mm bolts. I tightened them, then tightened this mounter, then loosened these a little bit, just a little, and started adjusting the gap. Here we have this washer. It's homemade. It fits very tightly into its seat, and it's very hard to move. Well, in general, the size is a bit off, so everything here is done with a hammer. I don't know, I think earlier I left some footage of how I was adjusting the gap. So I adjusted the gap with a feeler gauge, checked this gap basically until the gauge could pass through like this, 0.50mm. And then I tightened these bolts, so now they're tightened. Now my compressor is fully in working position. So now these bolts are tightened, and this is the gap I have. If I loosen these bolts a little now, just a little, my compressor will shift to that side, and I think the gap will change. With this gear, what nuance do we have? The old gear that we had on this engine had 30 teeth. This gear has 29 teeth. Well, that means we couldn't find another gear, only a gear with 29 teeth. So, according to the literature, it says that you can install either a gear with 30 teeth or a gear with 29 teeth. That is, they are interchangeable. Well, the only thing is that here we have an adjustment, so we need to tweak it a little bit. Although I just checked, the diameter of the gears is absolutely the same. Basically, this lever is now in about the same position as it was with the other gear, so I didn't notice any difference. In my experience, I haven't had to install a gear with a different number of teeth before, so I had some doubts. But since we couldn't find one with 30 teeth, we installed one with 29. So what I did was turn the engine clockwise and counterclockwise and check to make sure we didn't have any issues here. Well, if the teeth don't match up and at some point one tooth hits another, yes, but here I turned it and there was nothing like that. Everything turned smoothly, there are no problems. So now I'm going to close this front cover, install the pump, put the pulley here, put the pulley there. In general, assemble everything. I also want to paint all of this today, as I mentioned earlier. and tomorrow we're waiting for the turbocharger. Tomorrow there will be a test run, and probably tomorrow evening I'll be packing up the engine and putting it on the pallet. We'll be sending it to the customer. So that's the amount of work we have right now. Let's keep going. Now what I'll be doing while we're waiting for the turbocharger is preparing the pallet, the one it arrived on. I'll be checking it out. It's already been a month, even more than a month. So now I need to remember what was put underneath, how it was packed. Now I'll be checking and preparing the pallet. And I also need to pack all the old spare parts now because the customer asked to send all the old spare parts. Now I'll pack the flywheel, the disc. I also have the sleeves, pistons and so on, the old compressor, the pump. So I started the engine. As you can see, everything is fine, and yes, the engine is running. It was jumping on the table like this because I placed that block incorrectly, meaning its supports weren't there, it was moving around. That's why the engine was making those sounds. It hit the table with these pads, then I lifted the engine with the hoist, turned the block over, set it up, and after that everything worked fine. So our engine is running great. It starts smoothly, runs well, the oil pressure is good, 6 kilograms, but that's the maximum possible. There we have the relief valve working, which we installed, and the new spring we put in is set for 6 kilograms. When you rev it up, you can see smoke coming out. Because our turbocharger isn't connected, meaning we have an air manifold, the engine takes in air just from here, and the turbocharger produces pressure and pushes air in here. So basically we need to connect it like this so that the pressurized air goes into the air manifold. And obviously we end up with excess air of fuel. Then the engine will be installed in the car, the intercooler will be connected, so everything will be fine. And of course it still needs to be broken in so that it at least warms up to operating temperature. Then it will work completely differently. What should I do now? Now I'm removing the batteries. I took the batteries out of the bus. My batteries basically need to be put on charge. I just haven't gotten around to them yet. I took these batteries out of the bus. Now I need to install these batteries first on the bus that's standing over the pit. And then I'll clean up the diesel here, drain the oil. I've already taken out the oil pan there. So there will be some more shots of packing the engine, and then I'll be wrapping up the video. That's how our repair of the MAN D08-26 engine turned out, and that's the video we ended up with. Thank you all for watching. Good luck to everyone, and goodbye.